Okay, so just to focus on some of the questions you did in the test here, not the multiple choice questions. So we'll be looking at the 5 equations of motion because there's 5 quantities involved in looking at all motion. So you've got your velocity at time 0, or your initial velocity there, VO. So you could call it the starting velocity, but velocity at time 0 there. You've also got the velocity at time t seconds later. Now that used to be VT, and some of the books will still say V subscript t, but they've changed that recently to just a V, but that's based on the final velocity. So there are your 2 velocities there, start and finish. You've also got a change in the spatial position, or also called displacement. So that's given the symbol S to do a spatial position. But you can think of it as a distance in a straight line if you like at the moment. Acceleration is also how much it changes its rate of change of velocity. So does it speed up, does it slow down, and time. Now you've got equations of motion there that involve those 5 quantities, and each equation has something missing there. So look at the first one here, there's got no S in there. So you would use that equation if you're not trying to find S and you haven't been given S here. So for example, this first one, you've got a toy car starts from a rest, which means it's got a velocity at the start of 0 because it's at rest. Okay? V0 is 0. And it accelerates at 2 metres per second. So the A is 2. It's 2 metres per second faster every single second. And it's a period of time of 3 seconds. So there's a time there. So T is 3. And the question here is saying what's the car's speed after 3 seconds? Or in other words, what's the car's velocity after 3 seconds? So it's asking you for that V, and that's my question mark. So you could start when you're first learning this by putting down the quantities you've got and then selecting your equation. So looking at these here, we want the equation that does not involve S. There's no S in this, okay? So now S. So looking at that, we've got V equals VO plus AT. So you've got V is the unknown one, so we leave that as a symbol as is. We've got the V symbol we're trying to find, that's your X value if you like. VO was 0 plus A times by T, 2 times by 3. So you've got 2 times 3 equals 6 metres per second. Okay, so that's a very standard question, you don't have to rearrange it, very easy. In the second one, we asked about distance travelled there, which is your S value we're trying to find now. Now the reality is you've actually got 1, 2, 3, 4 values that you know and only one unknown. So you could have used any equation you like as long as it had S in it. I personally would choose an equation that I don't have to rearrange. So you can use the second one there or the third one. So if we're going to use S equals VAT plus a half AT squared. So we're going to leave the where S where it is, equals, so VO is 0, so 0 times by T is 0, because 0 times anything is 0, plus a half times acceleration of 2, so half of 2 is going to be 1, times by the T squared. So it's only the T that gets squared, there's no bracket here, and the T was 3. So if you do 1 times by 3 squared is 9, you get 9 metres. So that's a very straightforward sort of question there, okay? Now, some of the questions were more difficult for some students because there's little secret bits that they're not aware of. So if you're told that a ball is thrown straight up at 20 metres a second, the first thing you need to make sure you're not confused about is that that is the starting velocity when it leaves your hand and then it goes into the air. So that's going to be your VO, it's going to be 20. Alright? And then you're just being told by using equation motion to find the maximum height. So we're trying to find this change in position here till it gets to the top. So we're trying to find S. That's our unknown. So what else do you know about this motion then? At the moment you know that it's actually going to decelerate because of gravity, and the test has actually said to you that the acceleration is minus 9.8, which is 9.8 downwards. Okay? And on top of that, what actually happens when it gets to the top here, halfway through its motion? And the thing to bear in mind there, and a lot of people would have forgotten, is that the velocity is 0 at the halfway point. So you've got to really remember that to even answer this question at all. So if you don't apply the acceleration of gravity or the velocity halfway, you're not going to be able to answer the question. So the equation we're looking for here is one that doesn't involve t. There's no t in the question and you're not being asked to find time. So looking through those, you'll find you've got one that says v squared equals VO squared plus 2AS, 2 times A times S. So looking at that there, you substitute underneath there, the v squared is going to be 0 squared, because it's going to stop at the top. It started at 20 metres a second, so it's 20 squared. And then you've got 2 times by an acceleration, which is minus 9.8, times by the S we don't know. So when you're rearranging this here, you're going to get 20 squared is 400. Now this is plus 400 on this side. On this side it becomes minus 400 when you move it. This other side here, you've got two lots of minus 9.8, minus 19.6 times by s. Okay? So to rearrange the rest here, this is minus 19.6 times by s. We're going to leave the s alone, leave the minus 400 alone, and we're actually going to move this times by minus 19.6. So that's going to be divided by minus 19.6. So when you do that, you get s equals 400 over roughly 20. So it's going to give you an answer just over 20 if you go and check that out, okay? So it's going to be just over 20 metres. Let's say it's 20.4 if I was guessing there, but not so important there. You put that in the calculator. So that's the way to rearrange that sort of question there. But this is the important thing. You've got to remember that there, halfway through, the velocity will be 0, and you've got to apply that for things in free fall in the air here, okay, ignoring air resistance. If it then says what's the time in the air, you're trying to find time. You're now in a situation again where you know 4 things, you know you've got one unknown. I would choose the equation that was the easiest to find timing, so probably the shortest one. And if you go and check that out there, you've got V equals VO plus AT. So putting the things in there, you've got V is equal to 0 at the end there, halfway through the motion at the top. You start off with a speed of 20 metres a second, plus minus 9.8 lots of T. Okay. So again here, I'm going to leave this add 20 first here, make it subtract 20 on this side, minus 9.8 T. And you're going to divide through by minus 9.8 to get rid of that there, so the T is going to stay there, the minus 20 is going to stay there. I'm going to move the divide by, so times by minus 9.8, and make it divide by minus 9.8. And you're going to get T equals 2.7 seconds. Okay, 2.8 seconds. So that's how you can do that. Obviously the total time will be done with that if they ask you that question. This is just the time to get to the top. Some people rearrange this differently. They might actually say, look, I've got a minus 9.8 T. I'm going to go and do it as plus 9.8 T on this side equals 20, and then divide through by 9.8, and that works just as easily. So it's up to you. Right, I'm just going to do one more here. So in this one we've got something being dropped from a height of 50 metres. So you're going to imagine the cliff here, so it's a cliff. You're going to drop it from here, it's going to go down, it's going to travel 50 metres. So what do we actually know about this motion? If it's dropped, the starting velocity will be 0, because we're just only going to go. So VO is 0. Okay? It's falling due to gravity, so the acceleration is minus 9.8 because it's a going down motion, so it's going to be negative, that acceleration. Okay? Acceleration is always negative because it's towards the ground. We've got, don't know the finishing velocity there, but as it impacts, it's going to hit pretty hard though, and fast. We know it's got a height there of 50 metres, so it's going to fall down 50 metres. So downward motion means it's going to be negative. And we're being asked to find what this time? Calculate the time it takes to get to the ground. So in that case here, that's our unknown. So again, you can choose an equation without one of those quantities that are not involved here. So the only one missing here is the final velocity here. This one here is not needed. So if you go looking for that equation, you can see that there's one here that's looked like this. So in that case, we've got minus 50 goes in underneath for S. VO is 0, so anything times by 0 here is 0, so we can actually ignore that if you like, we'll put a 0 there if you like. Plus a half of minus 9.8 times by T squared. Okay, now just rearrange it any way you like here. So you've got minus 50 equals, what's a half of minus 9.8? It's minus 4.9 on the calculator. So again, it's up to you how you rearrange this, but I personally just leave the T squared alone, leave the minus 50 alone, and only worry about reversing the thing I'm trying to get rid of. This is times by minus 4.9. We want to make this divide by minus 4.9, and that's what your T squared is. If you do 50 over 4.9, you're going to get just over 10 there, okay? So it's going to be T squared is equal to just over 10. So it's 10.2 for example, and I'm just guessing that here without a calculator. So you do the square root of that, and that will give you your answer. So it's going to be 3 point something, I don't know, 3.3 metres a second. Sorry, 3.3 seconds. So I'm not bothered to actually calculate those. But that's the process I want you to follow. Alright? Thank you.